So this was the question, standing question. For how many integer pairs x and y the equation x square minus y square is equals to 66 are satisfied? The reason is what you did, x square minus y square is equals to x plus y into x minus y, and 66 is 2 into 3 into 11, and hence possible factor pairs of 66 are 1 and 66, 2 and 33, and 6 and 11. Now let us consider the following cases. Both x and y are integers, so they can either be even or be odd. So we consider these two cases. Both x and y are either even, or both odd. Then both x plus y and x minus y are even numbers. We do not have a pair of both even factors of 66. See, 1 and 66 odd, even. 2 and 33 even, odd. 6 and 11 even, odd. We do not have a pair of both even factors of 66. So both x and y cannot be even or odd simultaneously together. Next case, one of x and y is even while the other is odd. Both x plus y and x minus y are odd numbers. We do not have a pair of both odd factors of 66. One even, one odd factors we have always. Hence, there does not exist any integer pair x and y such that x squared minus y squared is equals to 66. Next question coming up. A large hall, read it carefully. A large hall contains 1,000 doors numbered serially from 1 to 1,000. So door number 1, door number 2, door number 3 up to door number 1,000. A group of 1,000 people are waiting outside the hall. A group of 1,000 people are waiting outside the hall. The first person enters the hall and opens all the doors. Okay, irrespective of the of whether the doors were open or closed, doesn't matter. The first person enters the hall and opens all the doors. Second person then enters the hall and closes all the even numbered doors. That is door number 2, door number 4, door number 6, etc. Closes all the even numbered doors. Third person then enters and changes the state of every third door. Like the third door, it was opened by the first person. So the third person goes in and closes the door. The sixth door was opened by the first person and then was closed by the second person. So the third person opens the sixth door again. Okay, did you understand? Changes the state, opens a closed door, closes an open door. Clear? The fourth person then enters. The fourth person then enters and changes the state of every fourth door. Okay, door number 4, number 8, number 12, etc. If this fashion continues, which are the doors remain open after the 1,000th person does her job? These kind of problems where you are stuck, how to approach a thing. A good thing to start with is to do this kind of weird numbers to reduce it to something more comfortable. So you can change all this 1,000 or this number 1,000 to 10 maybe, and do it actually. Actually, you calculate which are the doors. This is, you draw a picture of 10 doors and 10 persons going inside. So you find out which doors actually remain open. Then you do it maybe say 20 doors. Okay, so then you see whether you can find a pattern, and then if you can generalize that pattern to the actual number, that you have find a pattern, that pattern is correct. Every perfect squared number door will remain open. That is true. Now I want you to give me an explanation for that. Take this as as homework for today. Tomorrow in the next class, tell me the reasons why that should be true. So let us do something what is called contrapositive statement. contrapositive statement. Now, suppose there are two statements. Suppose P statement is the question, let's say, what is the capital of West Bengal? And my Q is the statement, the answer is Kolkata. Then we can write that this P implies Q. Do you all agree? Then P implies Q. Now, my question is this equivalent to saying that Q implies P? Is the question, what is the capital of West Bengal? And Q is the statement that P is the actual statement. The statement is, the question is, this is the question. Yeah, so this is the statement Q. The question P, the question is, what is the capital of West Bengal? And the Q is the statement, the answer is Kolkata. Now P implies Q, of course, but it is not equivalent to say that Q implies P. Of course, why? In this current scenario, you see, if I have the answer as Kolkata, then it does not mean the question has to be, what is the capital of West Bengal? Because Kolkata can occur as an answer to numerous questions. Okay, for example, where is Eden Garden situated? So the answer will be Kolkata. So answer is Kolkata. This statement does not imply the question has to be, what is the capital of West Bengal? Now, as Gracie said rightly, that negation of Q will definitely imply the negation of P. That if I have the answer is not Kolkata, then we can certainly say that the question was not, what is the capital of West Bengal? But negation, let me write, yeah, negation of Q implies negation of P. So this is what is called contrapositive statement. This is called contrapositive statement. Q implies P is same as negation of Q implies negation of P. This is called contrapositive statement. If P implies Q and Q implies P both holds true, if P implies Q and Q implies P both hold, then we call this if and only if condition. If and only if condition. If P holds, then Q holds. P holds only if Q holds. That means if P holds, then Q holds. This is this part. P implies Q. And P holds only if Q holds. That this is this part. Q implies P. This is called if and only if condition, and often written as this one, if. Don't do this. Yes. Please do not do this. I have actually set up a this thing shortcut to make if and only if always IFF. Okay, let it be. So IFF is, this means if and only if. This is the abbreviation of this phrase, if and only if. If and only if condition. If condition is this part and only if condition is this part. Now this is also called a set of necessary and sufficient conditions. Necessary and sufficient conditions. Okay, in short, we write this NASC, necessary and sufficient condition. Sufficient condition is this one, P implies Q. This is a sufficient. So if Q is mine, so if Q is my conclusion I want to make, and P is the condition for that, then P implies Q is the sufficient part, and Q implies P, this one, the conclusion implies the condition is the necessary part. Okay, this one sufficient part. This is if part. Sufficient is the if part, and this is the only if part. For example, a quadrilateral is a parallelogram if and only if the diagonals bisect each other. This is my condition. The conclusion is quadrilateral is a parallelogram. So where the condition implies the conclusion, that is the sufficient part or the if part, and where the conclusion also implies the condition, that is the necessary part or the only if part. So you have learned three abbreviations so far. One is WLOG, without loss of generality. IFF, oh please don't do this, IFF, and NASC. Okay, IFF is often written, is not often, always written in this way, small cap only, and WLOG and NASC, they are all caps.